Hello everybody, this is Tommy again. Now I know I said my last explainer video would be, well, the last one, but I guess something came up with grading and I'm gonna make two more, including this one, so yeah, that's gonna be fun. Alright, well this question asks, well, what is entropy? Some people say that entropy is disorder. Why is this a poor definition? That's because the word disorder doesn't really tell you anything and it could be subjective, and that's why it's just not a very good definition if we're talking about physics here, because we need concrete definitions, not something that can be subjective. How you really want to think about entropy is probability. Uh, it's really Entropy is basically in the most simple terms I can think of, the that it's more likely for heat energy to be spread out through a system, assuming that there's no external uh, force acting on the system, uh, rather than concentrated in a few areas. In order to relate this to the concept of microstates and macrostates, I could make an analogy to, say, like clouds or something. For example, each cloud is made up of like a unit of water vapor in a certain location, and each arrangement of these water vapors is going to be called the microstate, and the general shape of the cloud, like maybe it looks like, I don't know, a regular cloud, or maybe it looks like somebody's face or something. That general shape is going to be called the macrostate. And for that one, I'm guessing you already know that probably the most likely thing is it's just that the water vapor is just going to be all around anywhere, not in really any distinct shape. It's just going to look like, just big and fluffy, but you can't really make any general shape out of it. So it's just kind of well spread out. Uh, and of course, that's going to be what happens most of the time. I mean, how often do you see a cloud looking exactly like somebody's face or something? Probably not very likely. And I doubt most people will never see that in their lives. So the likelihood of something like that happening is just so small that we basically say that it almost never happens. Um, in thermodynamics, we assume that a system has a large number of microstates. Why is it important when we say that entropy always increases? Um, well, basically, it always increases because when we have, say, a hot object and a cold object, the most likely microstate that the molecules in each object will be in is having the energy, the thermal energy, become more spread out between both of them. So that basically just means that speaking in terms of molecules, it's more likely that you're gonna have energy from the hotter molecules moving into the the lower energy molecules, if that makes sense. So this might not always be the case for all the molecules, but since it's the most likely possibility for each molecule, um, generally when we're talking about like objects, there's a lot of molecules in each object. So generally, the hotter object will always lose its heat, and the colder objects in the system will absorb that heat instead. So that's why you will never see a hotter object get hotter or a colder object get colder without any form of external, I don't know, like work or force acting on the system. Uh, and that's basically my explanation of entropy. Thank you.